Alright, so this video is the introduction to our next unit, which focuses all on radicals. So, let's start talking about radicals. Before we do that though, we need to list some of our perfect squares and perfect cubes, and now perfect fourths. So let's go ahead and start listing them out. So the first few perfect squares, that would be 1, since 1 times 1 is 1, 4, since 2 times 2 is 4, we're also going to have 9, 16, 25, 36, 49, let's see, what's the other one, 64, and so forth and so forth. You should know those. When in doubt, just take a number and multiply it by itself. So now perfect cubes, same thing, but now you're doing it a third time. So we're going to have 1, 8, 27, 64. It's interesting, 64 is both a perfect square and a perfect cube. Interesting. 125, 216, 343, and so forth. Once again, you just take a number and multiply it by itself 3 times. Now perfect fourths. We haven't looked at these yet. So this is when you take a number and multiply it by itself 4 times. So that would be 1, 16, 81, 256, 625, got some big gaps between all these numbers, 1,296, and so forth. Once again, just take a number and multiply it by itself 4 times. So now, the parts of our radical here. So, let's read this statement right here. The nth root of a real number, that number being a, it can be written as the radical expression, the nth root of a. So let's fill in these blanks here. So the n that they have out here in front of the radical, that is called the index. The index, almost like an index card. Okay? The big bar looking thing, that is the radical sign. Not a very creative name, but that's what it's called. The radical sign. And then under the radical, or on the inside where the A is, that is the radicand. R-A-D-I-C-A-N-D, radicand. That's where your real number would go. And put a little star next to this note down here. If there is no index, so no number in front of my radical, then it's assumed that the n, in this case, would just be equal to 2. So if you don't see a number right here, that means that it is an implied 2. It's a square root. Okay, so for this next section, you're just going to be using your calculator for probably some of these. So it says, give all the possible roots to the radicals below. So, you should know this off the bat. What's going to be the square root of 16? It's going to be plus or minus 4. Remember, when you do a square root, you have 2 potential answers there. So the square root of 121, you should know that as well. That is plus or minus 11. Square root of 289 is plus or minus 17. Now I got a fraction over here. So square root of 4 over 25. Note 4 and 25 are both perfect squares. So I'm going to go ahead and try to squeeze it in. You can think of it as square root of 4 over the square root of 25. And you should know what both of those are. I'll put it up here since I'm out of room. When you do the square root of 4 and 25, you're going to end up getting plus or minus 2 over 5. Now moving on to the perfect cubes. So same idea. The cube root of 8 is going to be 2. And there's no plus or minus with the cube roots. No plus or minus, just the positive number. With the cube root of 343, you're going to get 7. Cube root of negative 125. Now, notice that negative right there? You're going to probably think that there's going to be an imaginary number that comes out of that, right? There's actually not going to be an I that comes out of this radical right here, because negative numbers can't have real number square roots. So you can't have a negative number, like you can't do the square root of a negative 16, and like you can't do that. But you can take the cube root of a negative number and still get a negative number. And here's why. So the cube root of 125 is 5, because, and in this case it is going to be negative as well because of that negative inside, because this is why. Negative 5 times negative 5 times negative 5 is equal to a negative 125. That's why that works. But if I were to look at my 16 over here, I can't do negative 4 times negative 4 and get negative 16. That's not how that works. You would get a positive number. So that's why if you have a negative under your cube root, it still is okay to have a negative answer. So with that in mind, let's move on to the next one. Cube root of negative 1 over 27. So our answer is going to be negative, like the last one was. It's because you can have the cube root of a negative. Cube root of 1, that's just going to be 1. And then cube root of 27, that is 3. So your answer for this one, it's a little spread out, is negative 1/3. And to solve this one, I just used the same process I did for this one, only now it's cube roots. So now on to the fourth roots. So fourth root of 1 is actually going to be plus or minus 1. So you're probably going to notice a pattern here. If it has an even index, if the index is even, you're going to have a plus or minus. But if your index is an odd number, like 3, 5, 7, all of those, it is not going to have a plus or minus. So keep that in mind when simplifying these. So I'm moving on. The fourth root of 2,401, you're actually going to get plus or minus 7. Fourth root of 4,096 is going to be plus or minus 8. Now we got another fraction, so use the same procedure for this one as you did for these, where you just took the root of the top and the bottom. So the fourth root of 81, don't forget your plus or minus, fourth root of 81 is going to be 3, and then the fourth root of 16 is 2. So we're going to get plus or minus 3 over 2. So now, moving on to this box down here. So keep in mind, if our index, remember the index is the little number up here, if our index is even and the radicand is positive, you're going to have a real type of roots, real number roots. You're also going to have 2 of them, and they can also be positive or negative. If your index is an odd number, but the radicand is positive, then you're also going to have real roots. But this time, you're only going to have 1 root, and it has to be positive. So 1 positive root. If the index is odd and the radicand is negative, you're still going to have real roots, real number roots, but you are only going to have 1. But now this one is negative, so 1 negative root. And this one is actually different. If it is an even index with a negative radicand, then your roots are going to be imaginary, and that's where the I comes in. Imaginary roots. And you're going to have 2 of those, with one being positive and the other being negative.